So let me cover up some of this ugliness that we don't really need to see right now. So section 4.7 should be the last section that we do this semester. Usually I don't cover 4.8 and 4.9. And I'll just kind of jump into this, and mostly I'm just going to do problems this morning. I made up a small example just to kind of describe the concept, and I'm going to just jump straight into problems. So the title of the section is Conditional Probability, and conditional probability is the probability that an event will occur given another event has occurred. This might not mean much to you right yet. Hopefully it means something to you by the time we get to the end of the chapter. I'm going to try to explain the concept of conditional probability using the game of blackjack. A lot of times probability and betting goes hand in hand. And let's say you sit down at some gambling establishment, if that doesn't offend you. I generally don't gamble because I kind of know the odds or the probabilities. You sit down to play the game of blackjack. In the game of blackjack, it's a card game. Sometimes we call blackjack 21. And in this card game, it's even if multiple people are playing, you're playing against the dealer in some sense. And we compare the total of your cards to the dealer's cards, and the person that is closest or equal to 21 without going over between you and the dealer will be the winner of that hand. In general, the chances of winning if you're playing the game and you're not the dealer, if you play perfectly in the game of 21, your chances of winning are, say, they're about 48%. This is playing perfectly. If you know the game of blackjack or 21, it's hitting when you should hit, staying when you should stay. If I don't know anything about a particular hand and I sit down to play, my chances of winning are 48%. Well, let's pretend I'm sitting at a table in Vegas or Laughlin or Phoenix, and I'm dealt two cards. I'm dealt an ace and a jack. And now I ask the question, what is the probability that you will win given the cards you have been dealt are an ace and a jack. This takes the question into the world of conditional probability. I'm going to compute the probability or talk about the probability that I'm going to win, that the event of winning happens, given that I've gotten an ace and a jack. So in general, if I don't know anything about my cards or I'm not card counting, the probability of winning is about 48%. In this particular hand, the probability of winning goes up really high. If I'm dealt an ace and a jack, an ace can count as an 11, a jack will count as a 10. My goal to win in a game of blackjack, you want to get as close or equal to 21 without going over. If you're dealt an ace and the jack, you can't lose. In the game of blackjack, if you get this would be called a blackjack, an ace and a jack, or an ace and any 10. If you get a blackjack, you can't lose. So the probability of losing it is 0% in this case if you're dealt an 8 and a jack. The probability of winning is kind of hard to compute because there's so many different cards. It's hard to actually nail this down to a number without teaching stuff that you don't ever want to probably learn, or I can't teach in a 1 hour video. But nevertheless, if these were the cards that were dealt to you, you can't lose. The worst thing that can happen is you can tie. In the game of blackjack, if you get a 21, you either win or you tie. If the dealer gets an ace, a blackjack as well, you tie. So even though I can't answer this question exactly because it's a little bit too hard to do the computation, but the probability that I'd win given the cards are dealt are an ace and a jack is pretty close to 100%. The only thing that can happen that is bad is that I could tie, but I couldn't lose. So in a generic game of blackjack, when you don't know anything about the cards, playing perfectly, you have a 48% chance of winning. This now is a conditional probability. The probability of winning this hand gets really close to 100%. So this is what I talk when I'm talking conditional probability. You know something about what's happened in a specific experiment. In this case, the experiment is playing a hand of blackjack. And if I give you some information about what's happened during the playing of that hand of blackjack, that can take the probability and make it higher or lower based on, whether it's a good or bad thing in some sense. So in this section, we're going to do lots of conditional probability questions, but we're going to be much more accurate than me just kind of waving my hands at it and saying this is close to 100% chance of winning, because the computation is kind of beyond the scope of our class. As we get through this section, there's going to be a handful of dice problems and card problems, and you're going to want to have handy something that has the sample space for rolling 2 6-sided dice. I'll flash it up on the screen. But this we created a few sections ago. And you're going to want to have a picture of a deck of cards in front of you. I have both of these printed out so I could do my probability questions. So let me just jump into the section, which is kind of not really the way I've been going this semester, but I think I can do this just fine without doing a bunch of problems. So the first 8 problems are conditional probability questions about a family having 3 questions. So I haven't done any examples, so this will be the first example, and let me just kind of jump into the problem. So it says create a reduced sample space and find the requested probabilities. Assume a family has 3 children, assuming that boys and girls are equally likely, determine the probability the family has. So for my question 2, what is the probability that a family has 2 girls if they have 3 kids, given their first child's a boy? So the first thing I'm going to do for each of the problems between 1 and 8 is I'm going to create the sample space, or a complete sample space, using a tree diagram for a family having 3 children. We did this earlier, so hopefully you haven't forgot this. If not, this would be good practice. So if a family has 3 children, if I wanted to make the complete sample space of the listing of boys and girls that are possible, the first child could be a girl or a boy. Make an arrow from the first child to the second child. The second child could be a girl or a boy. And we did this earlier, so I'm not really describing it so well. And the third child, so I'll go oldest, middle, youngest, I guess. The third child can also be a girl or a boy. So this is going to be a complete sample space that I would use for a non-conditional probability question. Remember, to create the sample space, we have to find a path to each letter in the far right-hand part of the tree, and there's 8 letters here, so I need 8 elements in my sample space. To get to that G right there, I'm just going to have a girl first, girl second, and a girl third. To get to this B, it's going to require having a girl as a first kid, girl as a second, and a boy as a third. To get to this G, it's a girl first, a boy second, a girl third. To get to this B, it's a girl second, a boy second, and a boy third. To get to this G, it's a boy first, a girl second, and a girl third. To get to that B, boy, girl, and then boy, girl, and then lastly, boy, this should be a boy right here. This is a mess up here. This right here should have been B. This should be boy, girl for this one, because this one should be boy, girl, boy, boy. I already listed boy, girl twice. That was bad there. This should be boy, girl. And this is boy. So these are all 8 elements in a non-reduced sample space for a couple having 3 children. Like we asked questions, I think it was in section 4.2. What's the probability that a couple has 2 boys and a girl? And you would create a fraction that would have an 8 in the denominator, and you'd count through the elements in the sample space to figure out the numerator. For our questions in section 4.7, what we're going to do is before we answer our probability question, we're going to extract the part of the sample space that fits the condition that's given, the extra condition that we know. So I'm trying to find the probability that this family has 2 girls, and in place of the word given, I'm going to put a straight line. Given the first child is a boy. To do this, the first thing I need to do is create a reduced sample space. I need to throw out anything from the sample space that the first child isn't a boy, and only look at the items in the sample space where the first child is a boy. For my problem 2, the part of the sample space I'm going to look at is the 4 elements in the sample space that have the first child a boy. So in my instructions it says create a reduced sample space. So what I did is I created the entire sample space for a family having 3 children, and then I created a reduced sample space. I looked in the problem about the information that was given. The information that was given is I know the first child is a boy. Now I'm going to find from this sample space the probability that the family had 2 girls. Now I'm just going to simply create a fraction, and the denominator of my fraction is going to be 4 because of the 8 items in the complete sample space, only 4 of them, which made it to the reduced sample space, have the first child as a boy. The denominator of this fraction for the probability is going to be a 4, and the numerator is going to be the number in this reduced sample space that have 2 girls. And in this sample space, there's one of them that has 2 girls. The other one either has 1 girl or no girls. So my probability is going to be 1 in 4. If you're going to do problem 1, the first thing you're going to do is read the question and look for the words after given, and that will help you decide on the portion of the sample space you need. And you're going to, in problem 1, need this portion of the sample space because that's the portion of the sample space where the first child's a girl. So the first thing you would do if you're attacking question 1 is dig through the sample space and find all of the elements in this complete sample space that fit your criteria and create a reduced sample space. And now when you go to answer your probability question, you're only going to look at these 4 elements of the sample space that had the first child a girl. So now what's the probability that you have 2 girls given the first child's a girl? Well, the denominator of that fraction is going to be 4 because our reduced sample space has a denominator of 4. And the numerator of your fraction needs to have, I'm assuming exactly 2 girls. It will have to be a 2 because there's 2 of the 4 items in your sample space that have exactly 2 girls, and I'd reduce that fraction. So your question 1 is going to have an answer of 1 and 2. Questions 3, 4, 5, 6, 7, and 8, we have to start off with the complete sample space that I created. So I'm just going to duplicate it on every sheet and not do the tree every time. So I'm just copying off screen the complete sample space that I created using my tree diagram. This is a non-reduced sample space for a couple having 3 children, listing boy and girl, first child, second child, third child, first assuming the oldest, and third being the youngest. So I'm going to do question 4. To do question 4, what's the probability that the family has more than 2 girls given the first is a girl? So both of us have the same given, so both of us are going to have the same reduced sample space. The first thing I'm going to do is ignore the part of the normal sample space that doesn't apply. All of these situations down here have a boy first, they don't apply. So I'm only going to look at the portion of the sample space that fits the information that makes this a conditional probability question. The denominator of my fraction for this is going to be 4 because there's 4 items in the reduced sample space that have the first child a girl. Now I need to figure out how many of those 4 items have more than 2 girls, and more doesn't allow equal. More means specifically more but not equal to 2. So I think that's the only one that would count for question 4. There's only one of them that have more than 2 girls, because more than 2 girls would be 3 or more. For your problem 3, for less than 2 girls, you're going to count up 0 girls or 1 girl, because 0 and 1 are the numbers that are possible that are less than 2. And you're going to form a fraction as well. And when you go to do your problem 3, I think it should be 1 and 4 for an answer. Because for less than 2 girls, given the first child's a girl, that's 3, that's not less than 2 girls. That's 2, that's not less than 2 girls. There's 2 girls, that's not less than 2 girls. I believe your answer should be 1 and 4. Let's move on and look at 5 and 6. I'm going to throw down this sample space again, taking up the time to write it down. This is the non-reduced sample space. I'm not going to use these 8 items to make my answer to my probability question. I'm going to have to sift through these 8 elements of the sample space and figure out which ones fit the conditions that are given to me. So for my question 6, what's the probability that I have 1 boy given the middle child's a girl? Well, my middle child is a girl are those 4 elements in my sample space. So I'm not going to look at the entire sample space when I go to answer this question. When I go to answer this question, I'm going to create a reduced sample space, and my reduced sample space is going to be the 4 elements in this complete sample space that have the middle child a girl. So the denominator of my probability fraction is going to be 4, because that's the number of items in the reduced sample space. My numerator needs to be the number of items in this reduced sample space that have exactly 1 boy, and there's exactly 1 boy, there's exactly 1 boy, so I have 2 items in my reduced sample space that have exactly 1 boy, and I'm going to reduce that fraction. My answer is going to be 2 and 4. When you go to do question 5, your reduced sample space is going to be similar, but the given is the middle child's a boy, so you're going to want those 4 elements in your reduced sample space. When you go to do the probability for number 5, your denominator is going to be a 4. It's the 4 items in the reduced sample space, the 4 items where the middle child's a boy. And then you'll need to count through and figure out the ones that have exactly 2 boys. And I believe your answer is going to be the same as mine, if I haven't messed up. One more with this sample space, so let me write it down again. The whole complete non-reduced sample space that we need for questions 1 through 8 deal with the family having 3 kids. And in a second here, I'm going to create my reduced sample space. I'm not going to use this entire sample space to answer my questions. So for problem 8, what's the probability that the couple has 2 girls given the oldest child's a girl? For my problem 8, I'm going to go through, I'm not sure now, oldest, middle, youngest, that's what I'm going to count it as. So the oldest child's a girl, oldest child's a girl, oldest child's a girl, oldest child's a girl. That's like the first child being a girl. I'm going to use that in my reduced sample space, as are you for your problem 7. So let's ignore all these. And when we go to do our probabilities, the denominator is going to be 4. It's the 4 items in the sample space that have the oldest child as a girl. For me, in my problem 8, I want the numerator to be the number of these 4 that have exactly 2 girls. This one is 3 girls, so that's not going to count for my numerator. This one has 2 girls and a boy. That one's going to count for my numerator. This one also has 2 girls and a boy. It's going to count for my numerator. And the 4th one has 1 girl. So I'm going to count these 2. I'm going to get 2 and 4 and reduce to 1 and 2. You're going to use the same reduced sample space when you do problem 7 because the oldest child is a girl as those 4. So your denominator is going to be 4. And your numerator is going to be the one in there that has the 1 girl. And if I haven't messed up, I believe your answer is going to be 1 and 4. The next chunk of problems has to do with rolling a pair of dice. And I always put these on the test. So for each one of these, I need to look at this sample space to start. This is a complete sample space. Before I answer my probability question, I need to create a reduced sample space. So my denominator is likely not going to be 36 for any of these probability questions. So as I read through the problem, it says create a reduced sample space and find the requested probabilities. A pair of dice is rolled and the sum of the dice is recorded. Determine the probability that. So this is the sample space for rolling a pair of dice. And now I'm going to move in and do problem 10. In problem 10, it says, what's the probability that the sum is greater than 9 given that the second dice is a 6? So the first thing I'm going to do is I'm going to create a reduced sample space. So I'll look through my sample space and find all of the rolls that had the second dice a 6. And I'm just going to write those down because it's going to help me not get distracted as I do my probability. So first step in all the problems in this section is to create a reduced sample space and ignore the big sample space. So this is when I go to answer question 10, I'm only looking at these 6 items. So I'm trying to find the probability that the sum is greater than 9 given with a straight bar the second dice is a 6. So immediately I create a reduced sample space. These are the 6 items in the sample space that have the second dice as a 6. So my new denominator is going to be a 6 for those 6 items that I just wrote down. The numerator needs to be any of them that have a sum greater than 9. The first one here has a sum greater of 7. That's not greater than 9. That won't count for my numerator. The second one has a sum of 8. That's not greater than 9. That won't go in my numerator. The third one has a sum of 9. That's equal to but not greater than 9. That won't go in my numerator. The fourth one has a sum of 10. The fifth one has a sum of 11. The sixth one has a sum of 12. All of those are going to go in my numerator, count for my numerator. In the reduced sample space, there's 3 of them that fit the criteria that the sum is greater than 9. The fraction I'm going to form is 3 and 6, and I'm going to reduce it to 1 and 2. For your problem 9, the criteria that's given for your reduced sample space is that the first dice is a 4. And the first dice being a 4 is going to give you, for your reduced sample space, a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, a 4 and a 5, and a 4 and a 6. So your reduced sample space when you go to do problem 9 is going to be 4 and 1, sum 5, 4 and 2, sum 6, all the way up to 4 and 6, sum 10. So you're going to take from the sample space all 6 items that have the first dice of 4, and you're going to have 6 items here. So when you go to do your probability, the denominator of the fraction is going to be 6, and then you need to count up for the numerator any one of these that has a sum greater than 5. And if you do that properly, I believe the answer you get for number 9 is going to be 5 and 6. Let me work through 11 with you and not do 12. So for number 11, I need to create a reduced sample space. As I read through problem 11, it says, what's the probability that the sum is even given that the second dice is a 4? So my reduced sample space is going to be all the items in this sample space. I give you this sample space on the test that have the second dice as a 4, so you don't need to create these. So my reduced sample space, write it down real quickly, is 1 and 4 with a sum of 5, 2 and 4 with a sum of 6, 3 and 4 with a sum of 7, 4 and 4 with a sum of 8, 5 and 4 with a sum of 9, and 6 and 4 with a sum of 10. That's my reduced sample space. Now I want to find the probability that the sum is even, given that I'm only looking at that sample space. Immediately, I know that my denominator is going to be 6 because there's 1, 2, 3, 4, 5, 6 items in that sample space. To get the numerator, I got to figure out what I count and what I don't count. I don't count this because its sum is 5, which isn't even. I do count this because the sum of that is 6, which is even. I don't count that because the sum is 7, which is odd. I do count this because the sum is 8, which is even. I don't count that, the sum is 9, which is odd. I do count this, the sum is 10, which is even. So my numerator for this probability is going to be 3. It's the 3 items in the reduced sample space that have an even sum. And then I'm going to reduce it. The answer for number 11 is going to be 1 and 2. All right, moving on. Ugh. These are harder questions coming up here. I'm going to do my 14 because I don't feel like doing your 13. For your 13, for your reduced sample space, you will need neither dice of 4. Let me just kind of mark through the ones you're going to count for number 13. And number 13, you're going to count those. I'm just going to mark through every one that you need to count for your reduced sample space. And it's a huge reduced sample space because as I read through your problem 13, it asks me to compute probabilities assuming neither dice is a 4. So what's the probability that a double is rolled given neither dice is a 4? This is your reduced sample space, and a double is getting 2 of the same numbers. So the numerator for your probability in number 13 is anything that I have a line through here. These are all the items that don't have a 4 on either dice. Your numerator for number 13 is going to be all the doubles, and doubles are having 2 of the same number. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Notice I didn't put a box around the 4, 4 because it wasn't part of the reduced sample space. So your answer to problem 13 is going to be a fraction. The numerator of the fraction is going to be the 5 items in the reduced sample space that are a double, both dice being the same. The denominator is the number of things that I struck through in green. And I believe if I look at my answer key and I did it right, I get 25. And then, of course, you'd reduce that to 1 and 5. Let me do number 14 just so you can see another one. For number 14, what's the probability that a double is not rolled, meaning the 2 dice aren't the same, given the sum is greater than 10? Well, this is a super easy problem because sum greater than 10, for my reduced sample space, I need to look at all the different items, and I want to only pick the ones that have a sum greater than but not equal to 10. My reduced sample space is so lovely and small compared to yours. My reduced sample space are the 3 items in the sample space that have a sum greater than but not equal to 10. So I'm not counting the 10s. So when I go to do problem 14, what's the probability that a double is not rolled given the sum is greater than 10? The denominator for my fraction is going to be 3 because there's 3 items in the reduced sample space that I created that have a sum greater than 10. The numerator needs to be the ones that aren't doubles. I'm going to count this 5, 6. It's not a double. I'm going to count this 6, 5 for my numerator. It's not a double. I'm not going to count that 6, 6 for my numerator because it is a double. So my numerator, I look through my reduced sample space, which are all the dice rolls that were had a sum greater than 10, and look for the ones that aren't doubles, and the aren't doubles are the 2 that I circled there. So it's going to be 2 and 3 for my probability. One last diced problem. So let's just do 15 together. In 15, what's the probability that the sum is less than 3 given the first dice is a 2? So I need to create a reduced sample space before I answer my probability question. My reduced sample space needs to be anything in the sample space that fits the criteria that the first dice is a 2. So my reduced sample space is going to have 2, 1 with a sum of 3, 2, 2 with a sum of 4, 2, 3 with a sum of 5, 2, 4 with a sum of 6, 2, 5 with a sum of 7, and 2, 6 with a sum of 8. That's my reduced sample space. I won't need the rest of the sample space anymore. I'll just throw it off to the side. And as I go to do problem 15, immediately I know the denominator for my probability is 6 because there's 1, 2, 3, 4, 5, 6 items in the reduced sample space. There's 6 items that had the first dice a 2. Now I need to figure out what I'm counting. I need the sum less than but not equal to 3. The first one I don't count because 3 is not less than 3. Second one, the sum is 4. That's not less than 3. I don't count it. In fact, I don't count any of these because none of them have a sum less than 3. To have a sum less than 3 would have to be 2 or 1. And there aren't any that have a sum less than 3. So my numerator is going to be 0. And this answer is going to be 0 because 0 over 6 is equal to 0. 17 through 24 are card probabilities. We're just picking one card from a deck of cards and finding some probabilities. Same thing here. These are conditional probabilities that I need to create reduced sample spaces. Let me work on your problem 17. And I'm going to get a little looser with my reduced sample spaces, and because there's just so many items. So for 17, what's the probability that the card is a heart given that the card is not black? So I know my card isn't black, so when I create my reduced sample space, I'm just going to cross out from the complete sample space of picking one card from a deck of cards, the cards that don't fit the criteria, I know the card that I picked wasn't black, so I'm going to throw these cards out. Those are the black cards in the deck. And what I have remaining, this is my reduced sample space. The fact that the card I picked wasn't black told me that it was either a diamond or a heart. The denominator needs to be the number of cards that are left here in my reduced sample space. My reduced sample space are these two rows of cards. There's going to be 13 hearts and 13 diamonds. The denominator for my probability for problem 17 is going to be 26. It's the 26 cards in the deck of cards that aren't black. The numerator needs to be the number of cards in this reduced sample space that are hearts. And the number of hearts in the reduced sample space needs to go in the numerator. And that's super easy for me to figure out. I look at the reduced sample space and I count every single heart. And the number of hearts in the reduced sample space become the numerator of my fraction. And because a deck of cards has 13 hearts, and because all the hearts are available to me, numerator is going to be 13, and this fraction is going to reduce to 1 and 2. Let's move on to the next problem. I'll let you do 19, and I will do problem 20. For problem 20, first of all, let me write down an answer for problem 19. For 19, if you're working ahead and don't want to watch me, I get an answer of 1 in 13. For problem 20, I need to create a reduced sample space, and the reduced sample space is what is the probability that the card is queen given that it's a face card. The reduced sample space is the face cards, and face cards are jacks, queens, and kings. So I'm crossing out every card in the sample space that isn't a face card, and what I'm going to be left with is my reduced sample space. My reduced sample space is going to help me with my denominator. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 cards in my reduced sample space. There's 12 cards with pictures of faces. So the denominator for my probability fraction in number 20 is 12. The numerator needs to be the number of queens in this reduced sample space. And in my reduced sample space, there's 4 queens. So my probability is going to be 4 and 12. And I'm going to reduce it to 1 and 3. For your problem 19, if you didn't get it already, for your reduced sample space, you're only going to look at the clubs and the spades. You're going to cross out the diamonds and the hearts, which are the black cards. The reason your denominator is 26 is because I know that the card is a black card. My reduced sample space consists of only the black cards, which are the 13 spades and the 13 clubs. The 26 I had in my initial answer goes with the 26 cards that are a black card in the reduced sample space. And then the numerator is going to be the number of 4s in the reduced sample space, the cards that I'm looking at, and there were 2 4s in the 26 black cards, and they reduce the fraction. All right, so, inclusive, exclusive. I'll do 22, and then you can do 21. It's slightly different. So the first thing I need to do for 22 is create a reduced sample space. What is the probability that the card is not a 7, given it's between 3 and 8 exclusive? Between 3 and 8 exclusive doesn't include the 3 and the 8. I'm only going to count for my reduced sample space 4, 5, 6s, and 7s. So I'm going to create a sample space. My sample space, I know that the card is between 3 and 8 exclusive, meaning it's a 4, 5, 6, or 7. So my reduced sample space for problem 22, what could have came up on my roll, are those. And I'm going to cross out the items that aren't part of my reduced sample space. I know that a card between 3 and 8 exclusive has been picked. And so the denominator of my reduced sample space needs to be the number of cards in the deck that are between 3 and 8 exclusive. That means not counting the 3 and not counting the 8, so just the 4, 5, 6, and 7s. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 cards in my reduced sample space, so the denominator for my fraction is going to be 16. The numerator for problem 22 needs to be the number of cards in this grouping that aren't a 7. And the number of cards that aren't a 7, I'll just highlight each one of them, are all the 4s, 5s, and 6s. And there's 3, 6, 9, 12 cards that aren't 7s in my reduced sample space, so my numerator is going to be 12. I'm going to reduce this fraction by 4 and get 3/4. When you go to do 21, your reduced sample space, you're going to focus on the cards between 3 and 8 inclusive, so you're going to include the 3 and the 8. Your reduced sample space for problem 21 is going to be all the 3s, 4s, 5s, 6s, 7s, and 8s. And so you're going to answer your probability question looking at those 24 cards. And when I go to form your fraction, my answer has a 24 in the denominator and a 20 in the numerator, and I reduce that to 5 and 6, I believe. I could actually find it. Yeah, 5 and 6. One more card problem. Might as well just do 23 with you. 23 is a lovely problem because the reduced sample space is so small. So 23, what is the probability that the card is not red given it's a queen? First thing I'm going to do is create my reduced sample space. I'm only going to look at the items in the sample space that fit the given criteria. And the given criteria is that the card is a queen. So when I go to do problem 23, the denominator of my fraction is going to be 4 because there's 4 cards in the sample space that fit the criteria that it's a queen. The numerator needs to be the ones that are not red. So now I'm going to go through and count all the cards that are not red. The Queen of Clubs, that counts because it's not red, because it's black. The Queen of Diamonds doesn't count because it's red for the numerator. The Queen of Hearts doesn't count for the numerator because it's red. The Queen of Spades does count for the numerator because it's black, which is not red. So I went through the 4 queens and I counted the ones that are not red, and I've got 2 of them, the Queen of Clubs and the Queen of Spades. So the numerator is going to be 2, and I'm going to reduce this fraction to 1/2. Now on to a new kind of problem. Not new kind, but new sample space. So assume that a hat contains 4 bills. It has a $1 bill, a $5 bill, a $10 bill, and a $20 bill. What's the probability that if 2 bills are taken out with replacement, what's the probability that ugh. I don't like these. So I wrote this material 4 or 5 years ago. As I look at problems 25 through 28, I really don't like the way they're written. They're written really, I guess at one time I thought they were written fine, but now I think they're written really poorly. I'm going to vote. Let's just skip 25 through 28 because I'm a bit confused of what was going through my mind when I asked these questions, and I either could fix the questions and do them or just ignore them. And it's the last section for the semester. Let's just skip these problems and move on to something that is worded a little bit better. It's just these are worded really poorly. Give myself a D- on wording these questions. So let's just kind of skip over these. Move on to the last kind of problem, which I always sneak on the test. And they're table probability, conditional probability questions. And they're tricky for students, but they shouldn't be. So let me just read through the questions or the statement a little bit. So at a zoo, a sampling of children was asked. Feels like word might be the right word. A sampling of children was asked if the zoo were to get one additional animal would they prefer, a lion or an elephant? So 360 kids were asked, we're going to get one more animal, would you rather have us get another lion or another elephant? And this is what they answered, and these are completely made up, I'm sure. 90 of the boys asked for a lion, 110 of the boys asked for an elephant. There were 200 boys, 75 of the girls wanted a lion, 85 of the girls wanted an elephant. There were 160 girls. So let's answer some probability questions. If we randomly pick one of these 360 kids, what's the probability that, and I will do 30 to start, the probability that the child is a boy given the child preferred an elephant? So what I'm going to need to do is I'm going to need to create a reduced sample space as I go through number 30. And in number 30, the information that's given to me is the child preferred an elephant. So what I'm going to need to focus on is creating a reduced sample space. And my reduced sample space is going to be this column of the table. The reason it's going to be this column of the table is because this is the column. This is the column where the child preferred the elephant. So I read through the question and I looked at the condition. The condition that was given to me is the child preferred the elephant, so I looked at only the column where the kids preferred the elephant. Now I'm going to answer my probability question. The denominator of my probability is going to be 195 because there were 195 kids that preferred the elephant for the next animal to be added. From this reduced sample space, what's the probability that the child's a boy? I just need the number of boys from this reduced sample space, and there's 110. This, I'm not going to make a stab at reducing this morning, so I'm going to 110 divided by 195. Math, enter, and you can't see that, but it reduces to 22 and 39. So my answer for problem 30 is going to be 22 and 39. Let me work through 29 with you real quickly, just to make sure we're kind of getting on the same page. So for your problem 29, what's the probability that the child selected a lion given the child's a girl? So I look at the word given. It said given the child's a girl. So I need to pick the part of the sample space or the part of the table that only focuses on girls. When I did problem 30, I picked the part of the sample space that only focused on elephants. So what I'm going to pick as I go to do problem 29, I'm going to pluck out the girl row. And I'm going to use it to make my probability. I'm not going to look at anything else in the table but well, if I could actually write this down right, I'm not going to look at anything but the 75, the 85, and the 160 that are in the girl row. I'm not going to look at this table anymore because it's not going to help me. So what is the probability that the child selected a lion given the child's a girl? The denominator of my fraction needs to be the number of girls, the total in the girl row, which is 160. And the numerator needs to be the number in this reduced sample space that selected the lion, and that's 75. So it's going to be 75 and 160. And assuming I reduced right, I get 15 and 32. I just stole it off the answer key, assuming that that's correct. Let's move on and do 31 and 32 and see how we can do those. So for problems, I'll do them both. You might want to give 31 a chance. And in 31, if you want to do it without me, I get 75 and 165. And I say it reduces to 5 and 11. So for problem 31, what's the probability that the child selected a girl given that the child prefer a lion? So I'm only going to look at the lion column when I go to do this. The information is given the child preferred a lion. So when I go to do problem 31, I'm only going to look at stuff in the lion's column. And this is my reduced sample space. My reduced sample space has 165 children that preferred the lion. This is why the denominator is 165, because I'm not looking at anything but that part of the sample space. The denominator is going to be the total from that row, which is 165, and then the numerator needs to be the number in this reduced sample space that are the girls, and there's 75 girls in that reduced sample space. This is why I wrote 75 and 165. If you don't mind, let's try to do 32 together, just because on the test a lot of students get these backwards. So for problem 32, what's the probability that the child preferred the elephant given that they are a girl? Boom, I look at the given that they are a girl, and that tells me I'm only looking at this. So as I go to do problem 32, I'm only going to look at the girl row because it says given that they're a girl. In the last problem 31, I only looked at the lion column because it was given a lion. So I'm looking at these numbers. I'm looking at the girl with the 70 with the lions, the girls with the elephants, and the girls with the total. When I go to answer my question 32, the denominator is going to be 160 because there's 160 girls. The numerator needs to be the number of girls that prefer the elephant, which is 85. I'm not looking at anything now except this little row of numbers. And I'm going to reduce that fraction, 85 divided by 160. Math, enter, enter, and I get 17 over 32 for my answer. We get a new table for the I think the last group. Remember, we have two tables left. I take that back. We get a new table for the next group of problems. And it's a bigger table, but it shouldn't be so hard for us. So a quality control inspector is checking a sample of light bulbs for defects. And it's kind of the same, isn't it? So he's checking 20-watt light bulbs, 50-watt light bulbs, and 100-watt light bulbs. Most of them are good. Some of them are defective. So there are 80 good 20-watt light bulbs, 15 defective 20-watt light bulbs, and so forth. So I'm picking, for my probability, I'm picking one of these light bulbs at random. What's the probability for problem 33, which we'll do together? The probability that it's good given that it's 100 watts. The first thing I want to do is only focus on the part of the table that has it's 100 watts. So I'm going to focus on the 100-watt part of the table. I'm going to write it down for myself here. So we have the watts, which are 100, and then there are some good ones in the 100-watt ones. There's 120 good ones. There's some defective ones. There's 10, and there were a total of 130. So what's the probability that it was good given it was 100 watts? There were 130 100-watt bulbs, so the denominator of this fraction is going to be 130. And of the 100-watt bulbs, how many of them were good? 120. So it's going to be 120 over 130, and that's going to reduce to 12 and 13. I'll flip on to 35 and 36. I'll let you do 35. And as an answer for 35, I'll write the reduced answer so I don't spoil it for you. I wrote it reduced to 2 and 5. I'm going to do problem 36 and leave 35 for you to do. What's the probability that I picked a 50-watt light bulb given it's defective? So immediately I looked to the word after given, and it said given it's defective, so I'm going to take the defective column. And in the defective column, some of the light bulbs are 20s. Some of them are 50s. Some of them are 100s. And we have a total. So I'm just plucking out this column so I'm not influenced of anything else other than the numbers I need to be looking at. So what's the probability that it's a 50-watt light bulb given it's defective? The denominator for my fraction is going to be 30. It's the 30 defective light bulbs. The numerator needs to be the number of 50-watt bulbs in this column, and there's 5 50-watt bulbs. So it's going to be 5 and 30, and that's going to reduce to 1 and 6. Finally getting to the very last table. So hopefully you did 35 just well. Fine. We have 37, 38, 39, and 40. And another completely made up table. I probably stole this off of Google Images because it doesn't look like a table that I typed. So a survey of students were surveyed to determine if they had oh my gosh, a survey of students to determine if they had a pierced ear was given. And so guys and girls were asked if they had pierced ears or not, and this is the table that tells me how these particular 500 students responded. So let's do 37 together. In 37, what's the probability that the student selected as a female given that they're pierced? In order to do problem 37, I need to create a reduced sample space, and my reduced sample space comes from the pierced column because that's what's after the word given. So after the word given, I see that it's pierced, and 36 of the males were pierced, had pierced ears, 288 of the females did, and there were a total of 324 students that had pierced ears. So the denominator of my fraction for my probability is going to be 324. That's the 324 students that had pierced ears. The numerator needs to be in this column right here, the number of females, which is 288. Let me just reduce that fraction. 288 divided by 324. Math, enter, enter. I get 8 over 9. So one more problem of new material, and then it's just all studying for the test. So I'm going to do problem 40. You can do problem 39. And for problem 39, I got 1 in 10 as a reduced answer. Let me work on number 40. For number 40, it says, what's the probability that they were not pierced given that they were male? So for problem 40, I'm just going to look at the males. So I'm going to look at the males, the 36, the 144, and the 180, which are pierced, not pierced, total. The denominator for my fraction in 40 is going to be the 180 males. The numerator needs to be the 144 that are not pierced. And I'm just going to reduce that fraction. My answer is going to be 4 and 5. All right, so hopefully that section went well. I taught it a little bit differently this time than previous semesters, and just because it's been kind of a glitchy section for students, so hopefully this explanation sinks in really well with you.